For the online class, I'm sorry there's no camera picture today. That's one of the things that caught up. You'd love it. I'm in high heels and, well, never mind. What we're going to do today is, let them wonder. I don't know. What we're going to do today is look at, we're going to continue our discussion of how we control dial plan entries. Now, towards the end of the course, or the end of our meeting last time, I mentioned that we've got a problem. If we start off looking at this with the way the PSTN worked, where we had fixed endpoints, and then I asked the question, what happens if these endpoints physically move? Because that whole PSTN structure and the way we've been looking at dial planning assumes that those endpoints don't move. In that thing that we've been looking at, where is the identity? We've mentioned this 2 or 3 times. Where's the identity for a given phone? It's on the interface at the switch. Okay. In our lab, and for this course generally, and in our industry generally, that's really not the case most times. It's still out there. We still have to deal with it. Mostly what you have now is an IP environment or some other packet voice environment. There are other ones out there. IP is the major one. And that endpoint's going to move. How do you find things on an IP network? How do you locate where they are and how do you get to them? IP. So if you want to get to Amazon.com, you need Amazon.com's IP address, right? Now, I may do that with DNS, Amazon.com. But DNS is going to go out and make that an IP address, come back and say, oh, this is what you mean, and then send my browser to an IP address. Okay. The problem we have with attaching phone calls to that, there are a lot of problems we have with attaching phone calls to that. For the purposes of discussing dial planning, the problem we have with that is how do I then associate a number with an IP address that's going to change? In one sense it seems simple. Well, make a registry. Okay. What about NAT? And NAT is a big problem with IP systems. We're not going to talk about it today, but I want you thinking. If I'm associating unique phone numbers with an endpoint that I'm specifying by IP address, NAT is an issue. Okay? I've got the same ports going to the same IP address. How do I do that? I'm not prepared to discuss that today, but those are the kinds of things we have to deal with. For today, we're going to look at how we do this association. How do we extend the idea of naming an interface with a logical address and extend that to making a phone number associated with a port that's going to move. The other change is when that PSTN view of the world came out. I'm going to go ahead and get my slides show started here. When that PSTN view of the world came out, there really wasn't, phones didn't have processing. A phone is an electromechanical device. It doesn't, the basic telephone doesn't have electronics in it. It has coils of wire and relays and switches and all that stuff. It's an electromechanical device. It's a very clever device, but it doesn't have processing power. Okay? That's all done by the central switch. Okay? In an IP world, what's that voice endpoint? Well, I showed you an IP phone like we use in the lab here. If you take the cover off of that, essentially what that is a computer in a case that looks like a telephone. And it has a network interface with a MAC address. It can do things that we expect computers in an IP environment to be able to do. It can ask for an IP address. It can ask for information about the local network from DHCP. It can learn all sorts of stuff through those supported IP processes that you guys have studied for a long time. It also can process locally, and in fact does. So the problem we have now, if I'm going to stick with the way that we've been looking at dial planning, and obviously we can't, then I'm going to have to put my dial plan on every single IP telephone in my network. Because the phone ultimately decides where a call goes. Now, granted, as we'll see later in the semester, typically the signaling part, the part of the call that sets up that end-to-end connection, only goes one place. Okay. The audio does other things. I'm getting ahead of myself a little bit, but I'm just showing you that it's a complex piece. What we're going to do today is extend that idea of which interface makes a decision and how the switchboard process makes a decision so that we can accommodate the fact that there is processing power on the phone end, and that before this ever a call that I'm making outbound ever gets to that IP switch, we've already made some routing decisions on it. Okay. So let's take a look at how the world we're going to play in. This is the lab equipment we'll be using. It's the identical setup you used last time. So in terms of reserving time on the lab station or reserving, getting into the lab station, logging in, all of that stuff, I assume you remember from last time. You may want to keep your lab 1 around for reference. So this part has not changed. What we're going to do, you have to have a little bit of a playbook here. We're going to emulate this network. Your lab station has a device called it's an Adtran NetVanta 7100. It is an IP communications platform. It includes an voice over IP PBX, which is the part we're going to be using today. Attached to that in our lab environment is an IP 706 IP phone, which is a hard phone. Let me grab one here. This is a device that looks like a telephone, but when you strip the cover off of it, it's going to look a whole lot more like a computer. It has processor, it has memory, has storage, has network interfaces. It's a computer that is designed to do voice, basically. There is one of those on your lab station. It's physically connected to port 24 on your NetVanta. Excuse me. In addition, you have 2 virtual machines on your lab station. We played with them last time. On each of those virtual machines, you have an Adtran soft phone. Now, soft phone is a computer application that emulates the function of a phone. Okay. So we've got 2 different ways we can use the power of this IP PBX. When I do this, we kind of talked through what we did already. We're going to use the MAC address of this phone. Part of the problem is, how do I make any phone that looks like I make it look broken by dropping it. Any phone that looks like this, how do I make this phone my phone? Okay. And the way I do it, we'll see a little bit of this today, is I actually tell the switch when the phone with this MAC address shows up, give it this configuration. Make it look like this. When the phone with a different MAC address shows up, if you know what that MAC address is, give it the configuration associated with it. So that's pretty straightforward. We'll actually go through that process in pretty fair detail later on. Right now I want to deal with the dial plan part of this. Part of what we're telling it in that configuration is what routing decisions the processor in this phone makes when I dial. Remember, we have a network interface in here already. I've got to decide what calls can go out of that, and I've got to decide how to process calls that come in. Okay. So we're going to look at the controls for that. Now, before we go any further on that, let's talk about the soft phone side of things. The soft phone, like I said, is an application you run on your computer. And it's designed so that you can run it from anywhere, and you can actually run it on multiple devices. So I might have a soft phone installed on my work computer that sits on my desk, And when I go home, I might want to work from home occasionally. I would have that same soft phone application, or another one, doesn't have to be the same brand, on my computer at home that I want to use with that same telephone number. So how do I do that? That's two different MAC addresses. So I can't associate with a MAC address. This is where we come full circle to that idea of identity. In the hardwired PSTN-style network, identity and network address are the same thing. It's your phone number. There actually is a layer of hardware addressing under the hood. We're not going to worry about it. Okay. What we're going to do here is separate that. We're going to create an identity, and that's actually what when we create user accounts, what we're doing is creating an identity. And we're going to associate that with either a particular hardware device, in the case of a phone like this, or with an IP address. Okay, fine, you say, but what if you log in with that once from your office and then log out and go home and log in from home? The IP address changes. Yes, that's true. So I can't do that. I can't do that permanently. What I can do is realize that that user account is an identity. We're not creating an account for John Hart. We're creating an account for a user that is my telephone number. That's the identity. I get to use it. But the account is for my phone number. And that account has a username. It is the telephone number. And when you log into a computer network, what do you usually have to do? I am, you tell it who you are, and the network says prove it. So you enter a password. When you create these accounts, you give it a username, the phone number we want to use. We're using the default password in the system. But I want you to notice when you go through that there actually is a password in there. Default password is very cleverly and securely 1234. So we'll leave it at that. All of our other passwords are passwords. Why not? So what happens now is when I have a soft phone that I want to associate with my user account or the phone number that is my user account, what I will do is have that. I'll tell the soft phone, here's the account, the username. Here's the password for that account. When you start up, go touch this server. We're going to tell it which server to touch and say who you are. And so when that soft phone starts up, we have programmed it with the domain. In our case, we're using IP, so I'll just give you an IP address in there, 10.10.10.1. That phone goes to the server, says, hi, I'm 1234, I'm 113. Server, being a good server, says, prove it. And it says, fine, my password's 1234. Okay, great. And it says, now, I see that you're coming from 192.168.1.230. That's where I'll associate you. Okay, so now, look what I have. I have an identity, what I say, 113. And I have an IP address where 113 is currently located. If I then log out, or even if I don't, if I move my soft phone to another network, for it to work, it's going to reach out and touch that server again, and that process is going to update the IP address where it is. Now, I realize from an IP point of view, this is very simple. You guys are used to that. You're probably waiting for the other shoe to fall. It really is that simple. The problem is when we start doing this with voice, with the way voice over IP systems work, we can get into trouble. We're not doing that today. We're not going to get in trouble. We're going to be nice. What I'm interested in today is how we associate that. We use that telephone number, the user identity, to route calls, and that's what we're looking for. Okay. Later on, we'll talk about the problems. Now, what we're going to do today is take advantage of that whole process and realize that since the identity and the device are separate, I can associate more than one identity with a single device. So in the case of this phone, we're going to configure this system so that this phone actually has 3 phone numbers associated with it. What are we doing? We're building 3 user accounts, 3 separate identities, and then we're going to take each of those identities and associate it with this one phone. Okay? We've created a multi-line phone. We can do the same thing with our soft phone. I can associate multiple accounts with that soft phone. And that's what we're going to do. So one of the important pieces you need to understand about this lab, this is why I draw pictures for this kind of stuff. You're going to log in here, and you're going to create users for your IP706 hard phone. I actually show that for all of them. You're going to use the IP706 for one of them, and you will build 3 users, 111, 211, and 311 for that phone. On your VM1, you're going to build 112, 212, and 312. And on your other soft phone, VM2 soft phone, you're going to build 113, 213, and 313. Okay? So 3 phones, 9 phone numbers. Why am I doing that? Because the way I want you to think about this, you need to understand this is what you're doing. But the way I want you to think about it once you get it built is this. Your phone that you're going to use as your desk phone to make test calls is going to be the soft phone on VM1, which while you're making test calls, you're going to tell it to be either 112, 212, or 312. Not all, one of. Okay, we're going to change its identity. Okay? The other users are associated with only 2 devices, but for this lab it doesn't matter. I want you to think about them as if they were completely separate devices. Okay? So why are we going through all this complexity? Okay. Why are we doing this to make it look like this? Why not do the other? Well, what I want to do is look at how we can control what this particular phone, your desktop phone, is allowed to do on this network. We're going to implement accept rules and reject rules so the thought works the same way we've been talking about, but we've got to add a piece in here because I don't have that specific interface connection here. Okay? And here's how we're going to do it. We're going to insert something that we haven't talked about before called a class of service. Now, this is actually a construct in software in the 7100. Okay? So you'll create you'll build all the user accounts, get all the phones working, everything's ready to rock. Part of that is you're going to associate them with a class of service, and that's where we're actually going to define what each phone is allowed to do. Basically what we're going to do, and I'll keep jumping back and forth between these slides, basically what we're going to do is set up 3 classes of service. One called open. If a phone is in the open class of service, it can call any other extension that exists. It's allowed to do that. Okay? We're going to create a second class of service that is called restricted. If that class of service is restricted, it's only allowed to call extensions that begin with 2 or 3. It can't call extensions that begin with 1. And the last class of service we're going to call closed, and it's only allowed to make calls to extensions that begin with 3. So we're going to accomplish that kind of thing we've been talking about. What have I really done? We've gone through that same design process that we talked about. First thing I said to do when you're looking at a design is to define your types of calls, right? 911, which by the way crops up in this. Long distance, LEC, on-net, other sites on-net, all of those kind of things we looked at and we defined a specific pattern for. That's what we're doing here. With this, since I've told you that we want to separate out who is allowed to call extensions based on the first digit, what do you suspect our number complete templates would look like? No fair looking. Let me redraw this picture a little bit and see if that helps. Here's our PBX, Oh, by the way, it's IP, but we're basically thinking like we've done. Here is one group we want to do. 111, 112. I had to look back over my shoulder, and 113. Here's another group, 211, 212, 213. Here's another group, 311, 312, and 313. Since I want to control who's allowed to call these different groups, those are call types, right? What would we say the call type for this group would be? How would we characterize all of the calls to this group, this site, if you want to think of it that way? 1XX. What about this one? 3XX. Okay, so there's the design part. Now, yeah, it's a really simple design. I understand that. But it does what I need to do in here. I've got 3 different types of calls. I mean, we could as easily have done this as LEC, long distance, and extensions. In fact, we started to, and it got too confusing too fast. So we rolled it back to this. Don't worry, we'll make it more confusing as we go along. I wouldn't dream of depriving you of being confused. So what we're going to do in this lab is implement a way to identify these calls as groups, and then we're going to build accept rules on that interface, except that interface doesn't really exist, does it? It does sort of. All of the devices here have interfaces, and those interfaces are known to this system, but they don't really exist as an interface that I can deal with that way. And that's where this comes in. Realizing that all of those extensions are registering with this system, what I'm now doing is creating something called a class of service that lists what each class of service is allowed to dial. So what you're going to do through the lab procedure is you're going to create one group that's allowed to call 1XX, 2XX, and 3XX. Which one would that be? Yeah, it would be the open one. We want it to be able to call everybody, so we're going to say, sure, accept these calls through that class of service. Okay. The restricted one, we said, only calls extensions that begin with 2 or 3. So what we're going to do is do a class of service whose interface is allowed to dial 2XX and 3XX, but not 1XX. Finally, our closed one can only dial extensions that begin with 3. So we're going to define a class of service that is only allowed to dial the template 3XX. We've kind of turned it around. Instead of putting the controls at the very endpoint, we're actually inserting something in the middle that will, all of the endpoints can go ahead and make calls. We're just going to change what they're allowed to do in the middle. Now there's more, I will tell you. Drawing direct comparisons between a circuit switch system and a voice over IP system is a little risky. They are different systems. They do fundamentally work differently. So I'm playing a little fast and loose with what's going on under the hood. I'm not stretching it too far, but let me give you the caveat that's not on the slides. You are welcome. Anytime you're in this system, you are welcome to look around, look at anything you want. You need to remember something about the equipment we use. It is manufactured by a group that wants to sell it to end users, and they want it to work with minimal configuration straight out of the box. Okay? I'm trying to teach you how to configure the system, so I really don't want it to work right out of the box, so these all be really short labs. So part of the procedure is I'm going to have you go in and blow away the factory. Actually, I'm going to have you load the factory configuration and then blow away all of the dial plan that's in there. There are parts of it you can't blow away. Those classes of service, there are several of them that are predefined, and you can't remove them. They're just built into the interface. Now, the way we wrote this lab, you don't actually see that interface anywhere except one place, And we walk you exactly through what to select, so you may not even notice it. Okay? All of that is a preface to say, if you go looking around the system, which you are more than welcome to, you may run into stuff that doesn't seem to jibe with this. I'm well aware of that. If that bothers you, then don't go looking around the system. If you want to look around the system, go right ahead. I'm glad to respond to questions on it. Just understand that I'm setting up a very specific environment to do a very specific thing in this class. You would never see this done out in the world. It doesn't make sense for anything. So what we've done here is taken this view where all of these phones, if you think about where their routed interface is in this switch, right? They all terminate in a switch. So from that point of view, all of these are local calls. One of the things you're going to learn gets really hard to define in an IP system is local. I can have a phone on my desk here in Murray, Kentucky, and have a local call to somebody sitting in Hong Kong. It gets worse when you think about enterprise networking. We'll do that slowly as we go through this class. So what we're doing is, instead of dealing with these interfaces as if they come directly off the switch. I see your hand. Let me finish my thought. I'm going to group those interfaces to match what I want the system to do, and then use class of service to control what the actual endpoints can do. That's what we're doing in this lab. Yes, it's confusing. Yeah, you'll probably have to go through this a couple of times. Okay? Yes?
Am I right in thinking that open, close, or restricted are only examples of class of service?
Yeah, I made up the names. Those are my names. A class of service is simply what users are allowed to do. Now, notice that nowhere in that conversation did I mention users. What you do is create the class of service, and then you assign that class of service to each of the user accounts. Each of the user accounts will have a class of service that it is assigned. So if I'm assigned to the open class of service, I being extension 111, then I am able to do everything the class of service for open is able to do. If I am assigned to a class of service called restricted, then I'm only allowed to do what restricted is allowed to do. Okay. As I mentioned, you will have to go I wouldn't be surprised if you have to go through the lab a couple of times. We do have it set so that you can start and stop. It's a long procedure. I understand that. I wouldn't want to sit through it in one sitting, maybe. Actually, I did, but these devices at their bottom line are routers. If you looked around the command line interface at all, it probably felt pretty familiar to you, having known iOS. It's different in detail, generally the same. The first part of this lab procedure, let's kind of walk through it a little bit. First part of this lab procedure, I have you pick up this copy of War and Peace I have. First part of this lab procedure, basically I have you return the NetVanta 7100 to factory default. We're going to do this at the beginning of every lab. Could you wait until somebody else did this lab, load their config, and say, I did it? Absolutely you can. You won't know how to do the next piece, but you can do it. So we're going to return it to factory config, like it came out of the box. Okay. I'm going to have you save that config before you make any changes. I'm going to have you save that to another file name that includes your username. And the reason is I want you to be able to access that specifically. Okay. Later on, I'm going to have you save your completed config as well, and I'm going to have you compare those two later on, not during this lab. But so you need to do that on the CLI. walk you through doing it. Yes, I know you'll see other people's configs there. I don't trust anybody else to do my work, and I would suggest you do the same. So after we get you to a factory default config, we're going to start building our dial plan. One note, it takes about 3 minutes for the 7100 to reboot. Basically what you do to return to factory config is erase the startup config and reboot. It will say, I don't know how to start, I don't have a config, and so it'll load one from protected memory, then boot, and that process takes about 3 minutes. Wait, if you do that, I've walked you through doing it from the command line interface, and you'll see the thing boot. You know, the last message that it gives you, or at least everyone I've seen, the last message that it gives you is that the voicemail manager application has successfully started, or words to that effect. I call it out in the lab. Wait until you see that before you do anything else. Or things like DHCP don't work on your VMs and stuff like that. It's just confusing. So wait until you see that before you go any further. Okay, once we go in there, I'm going to have you configure dial plan templates. Dial plan templates in this environment. I'm sorry? I call it out specifically in here. It's something like, let me find it. Voicemail mailbox manager has successfully loaded. So that's the last thing the 7100 does, and then you can log in. You know the DHCP is running and everything like that. Okay. The first thing we're going to do after that is go to the dial plan, and we're going to configure dial templates. Now, remember I said this box is designed to work out of the box in almost everybody's network, and that's exactly what I don't want in here. So the first thing I'm going to have you do is blow away all of the dial plan entries. It will let you blow everything away except 911 and 9911. See, it's not just me saying that's a big deal. So once you blow those away, we'll walk you through the procedure to enter 1XX, 2XX, and 3XX. Now, you are going to be using these procedures. In later labs, I'm not going to give you the keystroke by keystroke instructions. I'm going to say, build your dial plan. So that's about 2 pages collapsed into one instruction for the next lab. So pay attention to how this works and realize where it is. This lab is to help you learn where these pieces exist. Okay? So anyway, you'll go through that procedure. At that point, you've completed the dial plan templates. That is Section 3 of the lab. Section 4 is configuring this class of service. Like I said, there are several that are predefined, and you can't get rid of them. We don't have to use them, but you can't get rid of them. So you'll see them in there. We're going to take 3 generic ones that they leave. Do you remember the numbers? Sorry. What are the default? What are the ones we're editing? Is it 5, 6, and 7? We're going to take unclassified or undefined class of service 5, and we're going to rename it open. We're going to do undefined class of service 6 and rename it restricted, and we're going to take 7 and rename it closed. Okay, you're going to go through the process to set up that operation that we want. Realize what's going on now. We've defined templates, so we know when we have a complete number. Now what we're saying is class of service is going to control which extensions are allowed to make which calls. So is this an accept rule or a reject rule? It's actually a little of both. It functions the way we built this lab. What we're doing is actively allowing extensions to make calls that match these templates. Okay. we could as easily do this by making the default everybody can dial everything and then build classes of service that subtract that. Okay. Which one's right? Depends on what you're trying to accomplish. We took the easiest route and the clearest route this time, which is we're going to specifically allow only what each class of service is allowed to do. So what you're going to end up with is a class of service that does not include 1XX, for example. So when it sees a call for 1XX, it's going to act on that. There is no match, so what do? Notice also that in class of service, I'm not specifying exact extensions or exact match numbers. I'm using templates. So I'm talking about types of calls. That's why I beat on think of your templates as types of calls instead of places. That's why we design it that way. Okay. So once you get that done, you will at that point have all of your number complete templates. You'll have all of your classes of service which control what your user can do. What are we missing? Users. We haven't built any users yet. Never fear. Section 5, we're going to configure users. We're actually going to configure 9 users in total. 3 of them will be associated with your IP706, the hard phone. 6 of them will be associated with your soft phones, 3 on each. Okay. Now, when you do the configuration, you want to pay attention. The configurations vary slightly depending on whether that number is going to be associated here or the soft phone. You have an extra step if they're associated here. You actually have a couple of extra steps. An extra step in this piece. If they're going to be associated with the hard phone, we have to specify the MAC address they're going to. Rather than put myself in the position, I do learn after 13 years, of having to edit every single lab document that I put out if we make a change in hardware in here, you will find posted next to this lab in the Canvas page, you're going to find something called a lab station information. It just lists these variables. It's so I change one page of paper instead of searching through everything I've written in a semester. In this case, it's pretty simple. You've got 4 lab stations, 4 phones, therefore you have a MAC address for the IP706 for each lab station. Whichever lab station you're in, use the MAC address that's associated with that. Okay? You like that? Okay. So anyway, you'll go through. On the soft phones, we're not associating them with a particular physical device, so you don't have to do that step. You just leave that part blank. When you're through with that, you'll end up with 9 configs. Okay? Once all of the users are configured, now we have to associate those users because they just exist in that box. They don't belong to anybody. They just are there. So now we have to take those users and associate them with endpoints, either a 706 phone or your soft phones. And that's what Section C does. Section C actually does the 706. And what you're going to do is discover another piece that you created that you didn't even know you created. When you built a user that was to be associated with the 706, and you put in that MAC address, the system under the hood created a config file for this phone. You've renamed it. It's the default config file plus the MAC address of this phone. So now we've got something that is specific to the device you're going to put on a desk somewhere. Okay. You're going to go into that configuration and edit it so that all 3 numbers appear. The default is when you put the first number in and associated with this phone, that was the number associated with the phone. When you went back and put another one in that was associated with the phone, that's the default that's associated with the phone, and it forgot about the first one. Same thing with the third one. So if you just left it, this phone would only be associated with its 3rd number. What you're going to do is go in and edit the phone config so that all 3 lines show up. Now, since I am writing this lab to be included online, I don't actually have you look at this phone or anything like that. You won't pick this up. You won't make any calls from it. We can tell if you make calls. Later on, we'll show you how to tell if you make a call to it or not. If you want, if you're doing this in this lab, stop and look after you reboot the phone, which is part of the process. And you'll see that you have all three numbers on there. Okay. The other thing in terms of the 706 is the phone has to reboot for that config to be overwritten. And the way the system normally does that is you make those edit changes and you say apply and it'll say, okay, I'll get to that. And sometime in about the next 10 minutes, and it really is about 10 minutes, it'll reboot the phone. I'm figuring you guys probably don't want to wait for a phone to reboot at the convenience of some underloaded system here, particularly since you're the only one on the system. So I wrote into a piece of this, we're going to go down to the Ethernet switch part of the config in here, and you're going to simply toggle power over Ethernet. You're just going to turn the power off the phone and then turn it back on, and it'll go through its boot process and come right back up. Okay. Okay. Once you get okay, let me give you a shortcut that I'm not going to be able to avoid using. I can just tell. I used to use the term hard phone for this sort of thing. That term has taken on a different specific meaning, and I'm trying to get away from it, but I'm probably going to say hard phone to refer to this, a hardware phone. If I do, just go with me. Okay. The soft phones, we also need to configure. Only in that case, remember how the soft phones identify themselves to the system. I don't have a MAC address that the system is expecting to see. I need the soft phone to contact the server, say, I am, whatever this account is, here's my password, and the system say, okay. That configuration, if you think about the way it has to work, has to be done on the soft phone. So this next section, you're going to start your VMs. You're going to start the soft phone application in your VMs. And you're going to associate, you're going to have it, you're going to associate that soft phone with 3 of those identities. Okay. When you're through, you'll have 9 phones configured and ready to go. Okay. And at that point, we're going to make test calls. What I'm going to have you do is you're going to be sitting at your VM1 station. That's this soft phone. Okay. You're going to make test calls to all these other extensions. And remember, we're not thinking about them being on the same phone. We're looking at them as if they are physically separate extensions living who knows where. Okay. Now, remember that we associated with your phone 3 numbers. In the procedure, each of these numbers, each of these identities is associated with a different class of service. Part of the procedure is you're going to change the default that your soft phone uses to dial out. You're going to start with it as the open class of service, make your test calls. You're going to change it to the closed or the restricted class of service, make your calls, and then you're going to change it to your closed class of service. It's real important that you make that change the way the lab says. Out-dialing, unless you do some other tricks, and we'll probably use them later in the semester, there is a way to force it to use a particular line when you have multiple accounts. I don't want you to do that in this lab. It's confusing. So what I'm having you do is change the default line this dials out on, the default identity it uses to make a call. And that's what we've associated with the class of service. Okay? So what you'll in effect do is change the number for your phone. Okay. I know you can probably predict what's going to happen, but I want you to see how the controls mesh to make it happen. Okay. Once you get through making your calls, and we also describe how you can tell in this environment when a call comes in on phones and things like that. It's real important that you pay attention to the specific details, like how do you hang up a call. NetLab is an absolutely wonderful thing, but there are a couple of things it does not do yet. It doesn't pass audio across that interface. They thought they were programming routers. Nobody listens to a router. It's only later they added voice over IP, and they only did it on Cisco, and they only did it for Cisco Labs, where you're sitting in there with the stuff. I don't need audio. I can hear the phone. Well, that's not what we're doing. So we've set it up so that you get visual indication, but you have to learn how to interpret it, and that's written into this. Okay. Yes, I am beating on Net Development Group to pass audio across this interface. I'm actually trying to set it up with our campus telephone system so that you can use your cell phone to make calls into this and calls out. We'll see if that works or not. We'll see if it's allowed to work or not. It's kind of a risky thing. We had somebody a few years ago run up about a $20,000 phone bill bouncing calls off our switch to the Caribbean. So they're a little gun shy about letting just anybody loop through our system. Okay, once you complete all of that, and only when you understand how this system is doing what it does, how am I controlling who's allowed to call what, do I want you to do the Section 7. Obviously, through this whole thing, we've been using the GUI. We're going to use both GUI and CLI throughout the semester. There are a few things that it is apparently impossible to do from the CLI. I don't really believe that, but there's no way we've discovered, no way they've documented, and no way they're willing to tell us to do things like build a phone config from the CLI. So there are a few things like that that you have to do from the GUI. Like router config, once you've figured out how that config file works, it's actually a lot more efficient to sit down and just go through the command line or even use a text editor and build your config that way. And that's where I'm kind of heading you, so you can make an intelligent choice about that towards the end of the semester. But for this lab, I want you to kind of see the changes we've made. That's why I had you save that factory default setup config at the start. I'm going to have you save, I'm going to have you look at the startup config in the CLI. And you can actually, and there are commands in there, so instead of having to scroll through 14 pages of stuff that's not doing anything, you can actually, there are commands that we show you that you can actually strip out only the voice commands and bring them up to the CLI. So that's what we're going to look at. Now I want you to compare those two files. I'll let you do it on your own now. Later on, I'm going to have you pull both those files up and actually do a line-by-line comparison. And I'm going to see if you, well, I'll tell you about that later. Anyway, I'm going to have you do a line-by-line comparison in there. Do not forget to save the running config for your startup to this other file name before your time runs out, or you will need to repeat the lab. Okay. At the end, I have you save it up, and then clean up again. If you're in here, just remember people are going to come in after you. You don't have to blow away the config. It's part of the lab procedure at the start to load startup config from the factory default. Again, I'm well aware that you could wait for somebody to finish this and just kind of peruse their lab and say that you've done it. That's fine. It's your money for tuition. I think you'll learn a lot more if you go through the procedure yourself and do it. But I'm aware that it's possible not to. Questions on this? Yes, sir.
Roman numeral 7, 6D, there are two,
Hang on. Roman numeral 7.
last page,
Okay.
6D,
6D. Okay.
those are two commands.
Whoops. Okay. I'll correct the one that I post. Oh, yeah. Okay. After show 7.6D, after show run voice, that should be carriage return E. Sorry, I've got two commands on the same line. I'll fix the one that I'm getting ready to post on Canvas.
Show run voice is one line, and then show run full class of service.
Yes. Yes. That's the only one you found. I'm proud.
Well, the number 5 was a note.
Oops. I read it. It made sense to me. Where's that? Number 5 on that one? Oh. Yeah, well, I'll get rid of that. Law, sausage, and classes. What can I say? Yeah, that's what he was just saying. That was actually a note to me when he went through the config, and I left it in by accident. Yeah, that'll go. You can just cross that one out. I'll remove it. Okay. I would like you to do this. I would like you to complete this by class time Wednesday. I intend on talking about this more on Monday. So it would be good if you could go through at least part of it over the weekend. Ideally, you do it by 8 a.m. Monday, but I know you're busy. So I need you to do it by 8 a.m. Wednesday.
It's definitely due by class time Wednesday.
It's due by I'm sorry, yes. Actually, I'll probably make it 8 a.m. just because that's what I'm doing with everything. So 8 a.m. Wednesday is when it will be due. I am going to talk about parts of it Monday. Not now. We're going to use this setup and configuration, the actual write-up part. I'm going to give you another lab that you do on your own and write it up. And that's probably the way I'm going to do most of them in this semester. I'll show you how to do it, cookbook lab and all that, and then I'm going to hand you another one and say, okay, now you do it. And what you turn into me is a config and explanation of what you did. Okay. But for this, whatever notes you need to keep for yourself. See you guys. Be safe.